Thank you so much for the papers.
Oh, no problem.
Oh my.
Star Wars.
Yeah.
Hey Fatima, how are you?
So
Aaron, hi Aaron.
green setback, right there.
It's for you to know comes. Yep, please, thank you for coming. Please join me in congratulating London, Aaron, and Fatima. They've got awards on Sunnyvale. Well, I know that half of our meeting are the winners, so you're kind of congratulating yourself, but still it's a big achievement. So let me share for your approval a little plan for what we can do during the meeting. Just pretty standard thing that we can deviate if there will be important literature club or research results, but there is not much time until the end of semester, and since you were presenting at Senable, you already have some results, some new results, right? And it will be very pity to let them go, and anything that you do not prepare for publication within a couple of months, it's like a food. It's not fresh anymore. Even if you were not coming to Senable, it's a great opportunity. They do not check literally who came and who didn't came, and the deadline for their proceedings is last day of April, and they may do some exceptions, but not very big. So let's plan on everyone will be preparing manuscripts for this opportunity, and 2 months is reasonable time to compose stuff. While we will do a lot of editing in the group meeting and through feedback and judging works of others, if collectively we see that some works are good for proceedings and maybe good for something higher, we'll submit somewhere else, but it will be like a background level with a strict deadline. And we can chop future paper in standard sections and do one per week with little exceptions for a couple of meetings. When some of us are going, I think 2 or 3 people are going to MRS. London and Aaron, who else is going to MRS, was submitting abstracts? Okay. It's accepted, right? Presentation. Okay, and was anyone submitting to Orlando? I was. So you'll probably skip meeting and you'll have more time to writing. So I'll either go myself or ask someone to substitute. The abstract is primarily based on what Yuvan is doing. And in some sense, we are swapping the order and start from the end and go then to the beginning. It looks a little crazy, but it helps to organize things. So each meeting, please consider, if you do not have big protest, to collect like all figures that you think are good enough for the paper and put captions, and then we'll collectively edit and then do the same for each section. So for MRS, we may do also practice talks, right? Okay, so for most of you, it is not too new, but just in case, so David, you are invited to think about matching this deadline if possible. Even if you'll not match it, you'll have some write-up ready and that you can put somewhere else. So this conference gives opportunity to publish proceedings, and they are a little bit easier to complete because presentation at the conference is considered as one successful review that recommends for publication. So it will be only one reviewer compared to other journals and submissions. And I believe I have sent, or you can find it online, there are some really basic instructions. There is nothing special. There is even template with right fonts that you can put your name there. And I wasn't reading in details. The only thing I noticed compared to previous year that they encourage video abstracts. So if you have some movies, they happily accept it. Probably they're moving to completely electronic publications so that you look on your mobile device what are new articles and they start moving. Okay. So, and today we have volunteer from different department and different group. So Mary is first year grad student?
I'm indeed my second year grad student.
Okay, but it was some other projects, and you are at the beginning of independent computations pathway.
Yes, towards my master's. So.
Okay, so floor is yours.
Thank
and
you.
On one hand, we will just enjoy what you present, and on the other, we really want to encourage you to give very hard time.
Yes.
Help to improve what the results are.
Okay, perfect. Thank you for having me today as a guest speaker. So this project came about, and Dimitri, you're going to have to help me pronounce this name. Milchev?
It doesn't matter. It's they used to replace letter N to letter L, so it's a derivative of the name Nicholas.
Okay, so Miklichyn? Something like that. Okay, so she is from Poland, and she was interested in my first author paper as an undergrad. and my lead selenium system is passivated with ruthenium bipyridine complexes. So what I'm showing today is not that, but it's the concept of making these small quantum dots that can give us these behaviors, semiconducting material that can make charge easy to transfer between your conduction and valence bands, and what interesting semiconductor properties we can get with small quantum dots. So today I'll talk about the electronic properties of silver, metal, so some other metal, and to non-metal hybrid structures using density functional theory. And just a little bit of background on these systems and why they're important is that we can go ahead and get higher electric conductivity, these high temperature silver systems. So they've been shown to provide shorter path lengths for the transport of charged carriers, electrons and holes. So that's beneficial to that. And there's several different kind of configurations. I'll be talking about the alpha configuration of these silver particles. And I'm also going to show you some other materials like bismuth and other small metals have shown to enhance surface, like TiO2 surfaces to shorten that band gap, because as it is, band gap is pretty huge in some materials. So we're wanting to shorten things down to allow for that charge transfer to occur. Okay. So again, this is preliminary work. It needs work. I'm just going to tell you that right now. So anything you have to say to give would be very beneficial. So this is not exactly my master's thesis directly. This is leading to it. So there's much work to be done. So this is just the start of everything. So, okay. All right, so the motivation here with Alicia's work, the name I couldn't pronounce, is that we want to optimize the geometry first to see how these systems behave and see if we can add indium. Indium is another metal that she was interested in looking at, as it's shown to be a little bit better than CAD in CAD selenium. But again, this is it helped with improving the luminescence, which was the main purpose of the indium phosphorus groups that she looked at. And then to do that, we have to examine the geometry, morphology, and electronic properties first by looking at the band gap, the valence conduction bands, and then later on absorption properties. And she also, again, wants to look at the luminescence, which is related to use of indium.
Can I stop you?
Sorry, yeah.
So, please repeat it or give in different words. So, which industry and which experiment you want to trace?
Which academia?
Which industry?
Academia.
Which applications?
Application. Semiconductor materials. Solar cells.
Solar cells.
Yes.
Not bioimaging, not
You can.
cancer therapy.
I think it has biological applications as well. This is where I need to dig in a little bit further on this background.
But you have your own opinion. So, charge transfer.
Yes.
What you are considering isolated particles? What's why?
Well, okay, no. So you're speaking of the indium, right? So the goal, my understanding was we were to add the indium to the surface in some way to see if we change our band gap, change the electronic property, see if it enhances it, makes it more efficient. That was my understanding initially of adding the concept of indium, but I could be.
So you you study materials for some specific applications. Okay, is it done? Or you don't care about applications, you're just so excited about materials that you want to explore anything about them?
The optical properties. So this would be the so application process photovoltaics.
And are you looking more on chemical composition or size and quantum confinement? Or
Size and quantum confinement.
Or surface termination with ligands?
All. I think the last three that you
So
said.
you cannot select which one is more important.
I'm going to say from the results that I have preliminary, it's going to be probably quantum confinement, simply because I have some, but I'm not entirely sure. This is where I need to talk to Alicia and see what she had ideas for this, because there's still some questions we need to answer. But my gut feeling on this says I think quantum confinement is going to be the one, because these results are interesting.
I apologize that I'm holding everyone from
No.
seeing nice slides, but it looks like there is a danger of to scatter efforts in too many directions.
Okay.
And maybe you already have your own vision or maybe advice from some advisors how to narrow down the search.
I've not.
Because I've seen the slides and it looks like your efforts scatter so far that it will be very hard to consolidate.
Well, then this is where your help is really appreciated. So if I am scattering too much, then we can bring this back. Because this is there's a lot of room to wiggle here. There's, I think I have been given too much room, actually, to go through this. So I think Alicia's vision, and you saw the document I sent you, is very open-ended. This can go in several different directions. And regarding my master's thesis, again, this is going to be towards that direction, and really anything's possible at this point. So, from what you saw, in your professional opinion, what do you feel initially might be the...
No, let's
Okay. Let's go. Let's continue, and then you all can see what we're talking about here. So, these coordinates that some of them I'm going to be showing were taken from X-ray database. And then some from literature that were provided to me from Dr. Sands. So if you email a researcher, they will send you their initial coordinates. They're allowed to, and just remember to cite them. You want to give them credit. So I use density functional theory, or UDFT, which is ultra, if I remember correctly.
No,
No.
not ultra.
Is it?
You can ask everyone one by one.
David, do you know? No? Okay.
Keep asking.
Well, has anyone heard of this?
I'm looking it up right now.
Okay.
No, there's DFTU. I assume it's.
Oh, like DFT plus even.
No,
it's not.
not plus, not minus. And most of you are already doing it. I know. Let's keep the intrigue. I know that some of you know the answer.
Unrestricted.
Unrestricted,
What does
okay.
it mean?
I don't know. Something is not being restricted.
But what is unrestricted?
Spin.
So you can have spin up and spin down.
Oh, that would make sense.
So unrestricted spin.
Yeah.
Okay.
So you're doing the right thing. It is good that you're
Okay.
doing unrestricted spin.
So, whoops. Okay. So unrestricted spin, B3LYP. And the reason I chose this one is it tends to overestimate a little bit. So I tend to like this one a little bit better. And then this is just for all the metals in the system. Just wanted to make it easy for myself to use this basis set. And again, everything's done in vacuum.
The functionals don't care about the spin, though, do they? I mean, do you change the functional when you go from spin restricted to unrestricted?
I know the answer, but it's boring for me to answer. There's someone who doesn't know the answer to try. So suppose that functional doesn't depend on spin. But if you do have separate list of formulas for different spin projections. Anyone wants to ask?
You have different densities. For spin up and spin down.
Oh,
So you have
yeah, I
different-
suppose, so you have to treat them differently.
If you assume absence of interaction, then it is just additive. You have function of all electrons with spin up and function of all electrons with spin down and adding together. But this is needed for transition metals when number of spins up and spin down are not equal.
Okay.
So you have two electrons in each orbital, then you know for some systems you can just not measure because of some unspoken.
Okay. So with an open shell, you do need to use a different functional, but with a closed shell, you don't necessarily have to.
now it is formulated for both persistent and food. The letter U tells that one treats up and down spins separately.
Okay.
Like instead of putting two electrons in one orbital, it is different orbitals for spin up and spin down, and they may even have different slightly different equations, so sometimes not slightly.
So you have to solve two different sets of equations?
Yes.
Does it make it more efficient?
You cannot avoid it if you use magnetic materials in transition angles.
Okay.
If you try to skip it, then results will be very crazy, and your experimental collaborators will kill you.
So I'm curious, is the U, this is where, I actually explicitly put the U in my input file. Is that the same without a U?
If you, in today's, it will be a question that you should be able to answer in a presentation.
Oh.
But if the spin and multiplicity differ from, if multiplicity differs from 1, like if you typically put 0, 1 in
Right,
there.
right.
So if the number 1 is something different, like 2, 3, then it automatically puts, it works as if you put letter U in front of your function.
Okay.
So there is a little foolproof, and if you put multiplicity like doublet, triplet, quadruplet, it automatically recognizes that when it's understood.
I see. So this gives us more information, essentially.
Yes.
About this. Okay, got it. All right. Well, excellent. Perfect. Okay. Now I have not had Angel's class yet, which, by the way, starts next week. But what I can tell you is that silver sulfide has 3 different lattice configurations, if you want to put it that way. So if we look right here, this was taken from a 1967 paper from the Mineralogical Journal, where they found the stereographic projection of these, how basically the sulfur structure was shown here. So these are, again, configurations that, again, well, I'm going to study in a little bit more detail. But this is how they projected it would look from experiment, these sulfur structures in 3 dimensions. Now, this paper from Dr. Sanz's group, Javier Soares, this is a PhD student who's been very kind to stay in contact with me and provide the structure. The reason that I chose this one from this paper, which, by the way, wasn't the focus of this, they had a TiO2 surface where they stuck this sulfur, a silver sulfide structure on it and capped it with ligands to help aid and see it would change the structure, electronic system, optical properties. But I found it interesting because I was having trouble making these silver sulfide, silver phosphorus, silver oxide structures. They just weren't optimizing when I took them from bulk. So this one, they provided me with the initial structure, and they said this was their building model because they did a little analysis where energy per silver sulfide unit converged at 6 units. Figure 2 is not shown here. And they said it tended asymptotically to the bulk silver value, silver sulfide value. So that's why they chose it as their starting material. So I'll be showing this with my optimizations. They used VASP, and they used plane wave basis sets and GGA in their calculations, so I'll be using a little bit different. But that's okay. We're doing different things to it. Okay, so again, here's the structure. And as you can see, there was absolutely no change in the optimization that I used for DFT and the B3LYP and NL2DC. And the silver sulfide bonds were ranged anywhere between 2.6, you can't see it, but 2.6 and 3 angstroms. And the main point of looking at the structure is what information can we tell? I mean, this has 18 atoms. Maybe it might be beneficial to see what happens in this structure. Okay.
Wait.
Oh, wait.
Can you, yes. So It's not periodic, it's just cluster.
It's just a cluster, yeah.
Is it neutral? Do you?
Yes. Yes, it
Okay,
is.
so each ion is in its favorite oxidation state.
Yes.
It's
Yes.
documented.
Yes.
Okay.
That I made, they did me a favor, so, because making them from hand can be a little difficult. So nothing surprising here. All I wanted to show is that we just have localization in the occupied, and do not want to step on a chair, shown here. Localization on the silver atoms, these d orbitals, and then.
So it's hybrid. You couldn't tell that. Like,
Yeah, it's hybrid, yeah. So it'd be like, I'm looking, I guess it's hard for me. I want to say there's interesting behavior happening here. Kind
Why
of.
don't you put energies near the labels, like home and home.
Oh, okay.
Absolute energy.
Okay.
Let me give you a hard time for a second.
Okay. Okay.
What's your opinion about Koopman's theory?
Of what's theory?
Koopman's theory.
Ooh. I feel like I've
So
heard.
it tells that absolute values of home and human energies are like very good descriptors. They are observables. It is what one measures as ionization and affinity. And the numbers of absolute value of home and human are interesting thing for your peers to look at.
Okay. But I should include some values for these as well? Or
If
just,
you
okay.
If you systematically do things, you may do it.
Okay. Sounds good. So.
Interesting with the Lumo and Lumo plus 2 do not have much density on sulfur.
Yeah.
It's mostly on silver. No?
So, but this is what you expect to see. Kind of this guy, little bit of. Okay.
Okay.
All right. Excellent. Let's move on. So here's the gap of this, which is.
How do you know that it is a gap? Gap is between occupied and unoccupied.
Mm-hmm.
How do you know that the orbital where left edge of your curly bracket touches
Mm-hmm.
at 100 volt is occupied?
Well, I did this in Gauss view.
No, but do you have like another proof that the peak, the orbital at 100 volt is occupied?
I'd have to check that.
Because it's very suspicious. Typically, the gap is very near 0 and.
So you're saying that I got an artificial, like
It is a sub gap in the conduction band, but I'm not. I don't know if any of us is aware of material in the gap of.
That didn't make any
I was
sense.
trying to think, what is it, like a gamma ray?
Like even single atoms without any chemical bonds do not seem to have.
So I must have
gaps
grabbed a
more than-
subgap and not realized it.
It looks like you didn't count occupations. It's like subgap between two unoccupied orbitals.
Huh. Okay, I'll have to double check that. So this is suspicious. So I will re-examine this and make sure, because I did this with generating because my check files weren't doing what they're supposed to in CCAST. So I generated one in Gauss view, and that's how I populated my cube files. And so I must have grabbed something accidentally, or who knows. So I'll double check that. So here are the other two structures that I went ahead. This guy is still running, or he may be done. But this one on the left, I'm also running. So As you can see, I optimized them. They look fine. There was really no changes in the bond links. And again, I must have grabbed something wrong.
Now, even if it would be correct, inside your curved bracket there are several peaks.
There are several peaks.
Right?
Yeah, I see them right there.
There are ticks at like 200, 250, but in addition there are peaks. So it's
Okay. We'll have to see. I'll have to play around with this and see what's going wrong on those. So this is the only issues I had. So that was the conclusion for this part one. So now I have some homework to do and figure out what I grabbed wrong. So that will be that part. Okay, part two. Not Neil's one. Okay. So this is bismuth beryllium, if I said that right. And this structure is true in a sense.
what is typical oxidation state for bismuth?
I want to say
Telluride is under sulfur, so it's probably 2 minus. But is it?
this would have a 1 plus.
So bismuth is 1 plus.
No. The whole charge. Because bismuth is 3 plus, 3 plus, and then the 2 minus. So then that would be the 1. So this is how overall.
So for each player, and then if you have 16 of those, it will be 16 minus.
No.
I don't have any experience on bismuth, but just curious, what is typical oxidation state for this metal?
Oh, let's see here.
Like if you are mixing them 1 to 1, then you are working under assumption that preferred oxidation state is 2 plus.
Looks like bismuth is usually in the +3.
Okay, then upon optimization, it will corrupt heavily. If you just change shape to something.
And it does. So, what my attempt was, is that half this structure, when you look at it, kind of resembles this shape. So I just kind of filled it in to see if it would, come to that kind of configuration. But the reason the 3-dimensional cross is a good starting point, forget what the material is here, just look at the cross shape, is that a lot of this material can start here and then lead somewhere interesting. So from my first paper, that's what we did. Lead selenium prefers to V in this cross configuration, 3-dimensional cross. But what I did was I took the 3-dimensional cross idea and I applied it to the silver oxide. So if we go back, just imagine you have your silver and then your oxide, and then you snip these inner bonds. You take a broom to it and in Gauss view, and it rearranges. It does this. It squishes it down into a little hat. And then presto, if you want to call it that, optimize it, and then it pops out like a top hat. And this optimized. And actually, this is actually quite nice, I think. The only thing is I gotta take off these hydrogens and see if I can add some ligands to the surface and balance out that charge. That's part of the reason why I wanted to balance it out, was it had the hydrogens, and namely if I wanted to see if this would optimize. And it did. It did.
So you did some creative and artistic to create clusters that once brought you to successful images.
Yeah, and that was the difficult part, is whatever you make, it's not pulling tricks out of a hat, even though it may appear that I'm saying that. You have to go back to the bulk in the X-ray crystallography and check against it. Does this make sense? Does this look like something I could get?
It looks like you need input structures, and you're trying to solve this complicated problem yourself.
Well, I
You
did.
You shouldn't. You shouldn't waste your time and effort.
Well, I tried to originally, and I optimized once, and then it wouldn't optimize again. So I couldn't get this to converge. So this attempt was to try to, and this figure is not completely insane. When I originally optimized the one that did, it was similar, but the bonds were too far apart, and that's why I wouldn't optimize again. This is why I'm happier with this structure.
It is very, very, very high risk.
Is
you
it?
could be successful once and unsuccessful
Okay.
another 10 times. So it looks like you may need a procedure, regular procedure to screen clusters of different geometries. And there are databases of clusters.
Mhm.
So
I just may have to search for geometries that actually work.
in the COD, open crystallography.
Yeah, and that's the one I spend a lot of time in, and I was having trouble.
You are looking onto bulk, and there is a class of materials when small clusters are coordinated with ligands
Mhm.
and then crystallized. So it is a
Oh.
network of
I got
many
where you're going
clusters
with that,
together.
okay.
And then you do not a fantasy structure, that's something that is already observed in experiment.
Okay. So this essentially, I'll need to go back to the drawing board on this one. Okay. Do you feel like this structure has any validity, or it's just too risky at this point?
It may have validity.
Okay.
It looks symmetric, but if you are trying, so I'm developing an idea what you're doing, but it can be very wrong. Not what.
No.
So
Keep going.
it looks like Larry wants to deal with, to enter the field of cheminformatics and data science that establishes correlations between structure and property in statistical sense. But this science one needs a very large number of data. And a naive idea is to generate data yourself, but practically it would be better to steal it somewhere.
Yeah.
Or make ideally as a fantasy, make a script that will read geometry from database, quickly compute energy, and then enrich a database with like 1,000 numbers. If
Right.
you do things by hand, you will develop super great skills of chemical intuition. You will see how things are changing according to transition. But if you will not, with a human efforts, success failure ratio, you may get like 20 structures per year, which is
Not very
less
many.
that is needed for cheminformatics.
Right. That makes sense. Also, time is against me, so we want to be more efficient with this process. But it's a good thing to check. Creativity is not bad, but being efficient is just as important. So this is where I have a question for you. Is this right to say it like that?
I don't know. But if you want to think this direction and you want to help your audience to follow you, you may first draw, well, not necessarily right now, add to your slide the outbow for each localities. Do you really believe that all of us remember what is the last unoccupied shell of silver? You may like put it's like krypton is one like 10 D10 and one S for maybe something.
Okay. With that said, we just had the localized density of d orbitals on our silver atoms. And you can see shape there. This band gap seems reasonable.
So where is the coma? Where is the movement? But what is your? There is another sub gap between -11 and -10. How do you know that your sub gap between -5 and -3 is the right?
And this is where I have to check the energies.
Not only energies but occupations.
The occupation.
If you look into Gaussian output, you need to look what is virtual, what is occupied.
I thought I was grabbing the right ones. I guess I wasn't. Okay.
I have a question.
Yes.
Where is the Fermi level?
The what?
Where is the Fermi level in this class? Fermi level.
I can't hear. I'm sorry.
Fermi.
You know, Enrico Fermi.
Oh, Fermi level. I don't know. Would it be,
The good approximation is halfway between home and lumen. So if you know where is home, where is lumen, then you know where is your filtering level. But you need to.
but I need to confirm it could be either there
So
or
you
there.
need to look not only on energies but also on occupations. To determine that.
Well, I'm a little rusty on that, I guess, but I thought I grabbed the right ones, but I'll go and double check those. I guess. Oh, my question was this a trap state?
You need to look on orbitals.
Okay, no. Okay.
If they are localized on
Okay. All right. So much work to do there, and double check. You're right. And so here we go. It looked like it fell apart.
If you really need this bismuth telluride, and you know that oxidation states are 2 and 3, so the stoichiometry is opposite to, and there is an example of 2 and 3, like aluminum oxide, aluminum 203, and it's probably available in all databases. So you pull aluminum 203, replace aluminum to bismuth, oxygen to telluride, and then scale it up to 2 grams. And then as a starting point. It may fail again, but there is a chance of this.
Okay.
Less change of geometry.
So really, this is junk because it just we can't do it. Okay. So I kind of suspected. My first guess is that it was just not beneficial. And just to confirm, I was really trying to convince myself that, oh, maybe this is zigzag, but yeah, they should stay together, not blow off like that. So you can see how that looks. And this is our 111 structure. So no, it doesn't. And then this looks suspicious too because it looks like they're just localized to one side. So there's no like kind of going throughout the dot, well, what I thought was the dot. So that looks a little suspicious as well. And then this can't be as.
Here is again the 1-to-1 ratio, which would work only if they are in the same oxidation state.
Okay. So yes, conclusions, quite a bit to do. So I will go back and anyway, we're meeting tomorrow, right? At 11. Okay, so this was to start more or less testing what I do and don't know. There's some things to do still, which is good. It's all learning experience. So once I do have, and the structures I may use may not be these, may be modified with aluminum or different structures altogether. The goal is to see if we can add indium or this may turn into something different. But the skills that I used here, the take home I want everyone to know is that regardless if you want to try something fancy or new, these are great tools. Go back and look at these structures, know what you should get and know what you should not get. And then that's going to be a huge help, I think. Is there any questions, comments?
Okay, but thank Mary for being so great and so independent.
Okay, thank you.
Questions? No questions, so thank you once again. So, formal part of the meeting is done, so we need to go to food, and we can quickly check out again.
Thank you, Dimitri. Appreciate it.
Great pleasure.
Wow,
Favorite
it's
thing.
going infinity.
And then it will oscillate.